podcast where we will be covering. So,
Es que me da risa porque te ríes.
a mí me da risa porque me voy a escuchar de qué. Welcome everyone to today's podcast. Today we will be covering chapter 4 of Fundamentals of Building Construction. So this chapter we're going to be covering heavy timber and mass timber construction. So this material is not just taking the spotlight in the world of construction, but is actually a key player in the future of sustainable architecture. Timber is experiencing a revival in its impact on building design, structural performance, and environmental sustainability.
Absolutely. Timber has long been a staple in construction, but with the rise of modern technology, like mass timber, there's a real shift happening. We're seeing timber used in ways that we haven't seen before, like taller and more complex structures, which opens up the new possibilities for architects and engineers. In this episode, we'll explore these new possibilities and reflect on how they'll shape the future of construction.
That's right. So to get started, we'll first break down the fundamentals of heavy timber and mass timber construction. We will talk about their unique characteristics, how they evolve, and why they're becoming so relevant today. After that, we'll discuss their advantage, challenges, and the implication for building codes, fire resistance, and the environment.
So the first segment is understanding heavy timber and mass timber. To start off, let's define what we mean by heavy timber and mass timber. These are both forms of timber construction, but they differ significantly in terms of the materials and methods used. Heavy timber, sometimes called Type 4, construction and building codes, relies on large solid wooden members of framing. These include massive beams, columns, decking, and that typically range from 6 by 6 to 12 by 12 inches in size. Heavy timber is stronger and durable, and its ability to resist fire is one of the most important characteristics.
Yeah, so that's a good point, Itzel. So one of the defining features of heavy timber construction is actually the concept of fire resistance by design. So what does this mean? This means that large cross-sectional area of wood allows for slower charring when exposed to fire. So as the wood chars on the outside, it actually forms a protective layer which actually increases the material's fire resistance. This is something that many people don't fully understand. The idea that timber burns quickly is actually a misconception, especially with the larger pieces used in heavy timber construction.
Exactly, Daniela. Now, on the other hand, mass timber is a newer category of timber construction that uses engineered good products like cross-laminated timber, glue-laminated timber, and nail-laminated timber. These materials are created by bonding layers of wood together, which significantly improves their strength and dimensional stability. Mass timber offers the same benefits as heavy timber, but with additional advantage in terms of construction, efficiency, and versatility.
That's a great point, Yazmin. Mass timber's engineered nature allows it to be used in high-rise buildings, something that was once unthinkable with traditional wood construction. And because CLT and glulam are manufactured off-site, it's much easier to ensure precision and reduce waste. These panels can be customized to fit specific building needs, which gives designers a lot of flexibility.
Yeah, so right, as you mentioned, the introduction of mass timber has pushed boundaries of timber construction. So let's say, for example, there are now buildings being constructed with CLT panels that can reach up to 10, 12, or even 18 stories tall, which is pretty unheard of in traditional timber building. And that's where we see a real transformation in the way architects and builders think about timber.
And it's worth nothing that mass timber doesn't just offer structural advantage, It also has environmental benefits. As an alternative to steel and concrete, mass timber has a much lower carbon footprint. Not only is it renewable, but timber also stores carbon throughout the life of the building, which helps mitigate climate change. This is also one of the main reasons why mass timber is being promoted as a sustainable alternative in the industry.
So now let's dive into the role of timber in building codes. So traditionally, wood construction was limited due to fire safety concerns, but advancements in timber engineering have shifted how these materials are perceived. So heavy timber has its own classification in building codes, right? Particularly in the International Building Code, which is the IBC. The code recognizes it as type 4 construction, which means that it has its own fire resistance requirements. This classification is based on the ability of heavy timber to resist fire and keep the structure intact for a certain period of time.
That's a great point. One of the challenges with timber in building codes has always been addressing fire safety. The IBC includes provisions for heavy timber specifying that timber members should be of certain minimum dimensions to ensure fire resistance. For example, beams and columns must have at least 6 inches of thickness in each direction to meet fire resistance standards. This requirement helps timber structures perform as well as, or in some cases better than, steel and concrete under fire conditions.
Exactly, but when we move to mass timber, things get a little more complex. The 2018 IBC made some strides by introducing new provisions that allow for taller mass timber buildings. Previously, mass timber buildings were not categorized separately, but revisions to the IBC are now paving the way for taller buildings made from CLT and glulam. For instance, some cities are not permitting mass timber buildings of up to 18 stories.
That's a major breakthrough, Yazmin. And as mass timber construction continues to evolve, we'll likely see even more changes in building codes to accommodate for this material. For example, there are emerging guidelines about using mass timber in areas with seismic activity, wind load considerations, and even snow load requirements. Each of these will be critical in ensuring mass timber is as safe and reliable as other construction materials.
And yeah, for sure, it's not just the building codes that are evolving. Sustainability standards like LEED and well building standards are also increasingly acknowledging the benefit of mass timber. As these standards recognize the environmental performance of timber, there's more demand for timber in both commercial and residential buildings.
Okay, so let's dive deeper into fire resistance. As we mentioned earlier, one of the key benefits of heavy timber construction is its fire resistance, but that's often misunderstood. The large wooden beams and columns actually perform very well in fires because of the shearing process. As good burns, it forms a protective layer of charcoal, which insulates the core of the timber and slows down the burning process.
Exactly. In fact, the char layer can actually enhance the fire resistance of timber. Research has shown that the thicker the timber, the better it performs under fire conditions. The fire can burn the outer layer, but the core of the timber remains structurally sound. This is why large timber beams can outperform steel beams, which can lose their strength when exposed to high heat.
Yeah, and it's important to understand that the fire resistance rating of a timber structure can actually be calculated based on its thickness and the char rate. So, this is why buildings with heavy timber elements often receive a fire resistance rating of about 1 hour more or less. When a building is designed using timber, the fire resistance rating must be determined by testing. But with the right specifications, it can meet the required standards for most commercial and residential applications.
However, but for taller mass timber buildings, additional fireproofing measures are required. This is where encapsulation comes into play. Encapsulation refers to wrapping the timber with fire-resistant materials such as gypsum, board, or insulation coating. These materials provide extra protection to the timber, ensuring it meets safety standards without compromising the design or aesthetic of the building.
It's worth noting too that fire safety is one of the key drivers for innovation in mass timber. Manufacturers and engineers are working closely with fire safety experts to develop new ways to protect mass timber buildings. For example, there are now innovations in fire-resistant COT panels that incorporate fire retardants additives into the wood itself, providing enhanced protection without the need of additional coverings.
Okay, so now let's talk about sustainability, right? So mass timber is being hailed as one of the most sustainable building materials available today. Unlike steel and concrete, which are energy intensive to produce, timber is renewable, biodegradable, and can isolate carbon. Timber construction can significantly reduce the carbon footprint of buildings, and it's even possible for mass timber buildings to have a negative carbon footprint due to the carbon absorbed by the wood over its lifetime.
And that's one of the most exciting aspects of mass timber construction. The production of timber products like CLT uses less energy than producing steel and concrete. This means that in addition to reducing the embodied carbon of a building, timber also helps offset emissions during the building life cycle.
As we think about the future, the importance of sustainability in construction will only grow. There's increasing pressure from governments, corporations, and the public to adopt greener building practices, and mass timber could be the key to meeting these demands. Not only does it help fight climate change, but it also improves the overall health of the buildings by increasing air quality and comfort.
Yeah, and more so, sustainability doesn't just stop with the material itself. So timber buildings are designed for disassembly, right? Meaning that at the end of their life, like any material, they can be easily taken apart and the materials can be reused or recycled. This is in contrast to concrete and steel. You can't do that with those, which is often, they often end up in landfills.
It is a truly circular approach to construction. Timber buildings can be part of a regenerative building ecosystem where materials are used, reused, and recycled, creating a more sustainable and resilient future for the construction industry.
So now we're gonna be discussing the design and engineering considerations when working with timber, particularly for heavy timber and mass timber buildings. One of the key aspects is ensuring that the connections are designed properly. Since timber has a natural tendency to shrink and swell, it's essential to account for these changes when designing joints and connections.
Yeah, and that's right itself. So the design of connections is one of the most critical factors in ensuring the stability of timber structures. For example, with mass timber, designers often use steel connectors or bolts to secure beams and panels. But it's essential that these connectors are sized properly to account for potential shrinkage or movement over time, like you were saying.
And as more timber buildings are going up, the need for advanced engineering techniques is increasing. Computational design and modeling are now being used to optimize timber structures. This means they ensure they meet both aesthetic and structural goals. The use of software that can simulate the behavior of timber materials under different conditions allows engineers to fine-tune designs for maximum performance.
Okay, so as we begin to wrap up today's podcast, it's clear that heavy timber and mass timber are not just trends, right? They represent a fundamental shift in the way we think about building design and construction materials. Sorry. We spent the last minute unpacking the significance of these materials, their historical context, and how the revival is influencing both the built environment and the future of sustainable architecture. So it's easy to overlook the power of timber as construction material, especially when we're surrounded by steel and concrete, right? But as we've discussed, timber is making a major comeback. And this isn't just a passing phase. It's a response actually to global challenges like climate change, of course, resource depletion, and the growing demand of energy efficient buildings. Sorry, we're very happy.
Absolutely. When we think about timber, we're often thinking of something that's been around for centuries, but it's the advancements in engineering and manufacturing that are allowing us to rethink timber's role in modern architecture. Mass timber in particular is a game changer. The ability to build structures that are not only sustainable, but also durable and fire resistant, that's something we haven't done before. The innovations in cross-laminated timber, which is also known as COT, and glue-laminated timber, known as glulam, have made it possible to build taller, more complex structures with a material that is renewable, carbon storing, and far less energy intensive than the traditional construction materials like steel and concrete.
That's such an important point. Mass timber is pushing the boundaries of what we thought was possible with wood. It's not just about building low-rise buildings, either we're talking about high-rise timber buildings, some of them as tall as 18 stories. It is a testament to the versatility and strength of these materials. What's more, mass timber allows for buildings that are not just structurally sound but also visually stunning. Architects are embracing its natural beauty, the warmth of the material, and the connection it provides to nature. Mass timber also offers a completely different aesthetic experience compared to steel and concrete. Mass timber also uses the goods grain, color, and texture to introduce a sense of comfort, warmth, and connection to the environment that isn't matched by other materials.
Yeah, and I totally agree with that. It's the aesthetic appeal paired with the timber's environmental benefits. That's really driving its resurgence. So we talked earlier about the carbon aspect of timber, how trees stores carbon dioxide as they grow, which is released back into the atmosphere only when the wood decomposes or is burned. In a mass timber building, however, the carbon actually remains locked in the wood for the life of the structure. And if that timber building is later deconstructed and repurposed or recycled, even more carbon is kept out of the atmosphere. This makes timber one of the most sustainable building materials that we have today. It's essentially a carbon sink in the form of a building.
And in my opinion, I think that's one of the most exciting aspects of timber construction. We're seeing the development of what's called a circular economy in the construction industry, where buildings are designed to be disassembled at the end of their life and materials are reused or recycled. Timber, unlike steel and concrete, is renewable. We can grow more trees, process that wood into usable building materials, and build structures that, when they're no longer needed, can be dismantled and repurposed. The ability to close the loop is such a powerful and sustainable approach to construction. It is one of the reasons why so many architects, builders, and developers are turning to mass timber for their projects.
That is true. We're at the intersection of environmental responsibility and innovative design, and timber is leading the way. But as we discussed, there are still challenges that come with working with timber, especially when it comes to building codes and regulations. For a long time, the construction industry viewed wood as a less safe option compared to concrete or steel, primarily due to concerns about fire safety. But as we've seen, heavy timber actually performs incredibly well in fires. The charring process forms a protective layer that helps slow down the spread of flames and maintains the integrity of the structure.
And that fire resistance that we talked about, along with the strength and stability of timber, is actually what makes it a viable alternative to steel and concrete, right? It's also why building codes are evolving to allow for taller mass buildings. As we've noted, cities are now permitting mass timber structures to reach up to 18 stories high, like we mentioned. And with innovations in fireproofing methods like encapsulation and fire-resistant coatings like timber buildings are becoming safer and more reliable than ever. It's a great example of how the construction industry is constantly evolving to meet demands of safety, sustainability, and innovation.
That's right. And when you think about the environmental context, especially with the growing concerns about climate change, timber construction presents an immediate practical solution. The energy it takes to produce steel and concrete is enormous. Timber, however, can be produced with far less energy. The production of CLT and glulam uses wood that's sourced from sustainability managed forests, further reducing the environmental impact. Mass timber also encourage a more responsible approach to forestry, ensuring that trees are harvested in a way that promotes long-term sustainability.
That's something that we really need to keep in mind. Timber is a part of a broader conversation about sustainability in the construction industry. We're seeing a shift toward designing and building with materials that don't just reduce our carbon footprint, but they actually help reverse some of the damage we've done. And timber is one of those materials that can play a huge role in creating a more sustainable built environment.
Yeah, and for sure, I think there's something soothing about the presence of wood in a space, right? It's warm, it's inviting, and it can make a building feel like it's part of the natural world rather than like an isolated structure. And as we have moved further, into the digital age and technology continues to dominate our lives, I think that there's an increasing desire to like reconnect with the natural world. Timber in all its forms is an incredible way to do that within the built environment.
So when we look back on everything we have discussed today, from the structural benefits and fire resistance of timber to its environmental advantage and design potential, it is clear that mass timber is more than just a material choice. It is part of a larger movement towards a more sustainable, efficient, and human-centered future in architecture. It is not just about what we build with, but how we build it and what that says about our priorities as a society. Timber is a material that helps us rethink construction in a way that benefits both the planet and the people who live in it.
So to everyone listening, we hope this deep dive into heavy timber and mass timber has given you a better understanding of not just the technical aspects of these materials, but also their broader implications for the future of architecture and the built environment. We're in an exciting time for sustainable construction, and timber is leading the charge. It's a material that connects the past with the future and tradition, and innovation in one.
Yeah. So thank you all for joining us today. Stay tuned for the next episodes and take care, everyone.